Hi, this one is about quantum mechanics. It's not very well prepared. I just try to improvise. One of the things you always read about quantum mechanics is that it ends determinism, and it does this because you can have exactly the same starting situation and you can end up with different outcomes, which means that there is some indeterminacy where matter can apparently choose its destiny. And that's not just any amateur bullshitter that says that. Like Brian Greene, for example, written quite a few books, says, end of determinism. And it's not as with chaos theory that when you read on that they kind of admit that it is deterministic, but it is sensitive to initial conditions. No, they really claim that its reality is really indeterministic. Although it must be said that they still hold true to the fact that the probabilities on time t+1 is uniquely dependent on the probabilities on time t is 1. So probabilities are still uniquely evolving through time through an equation that you can just uniquely determine. So if you know the probability of a quantum state at some point, you can be certain about the probability of the matter in on the next moment. You can calculate all the probabilities, and there's no exception to that, and it's never been found. So it still does not cannot explain anything like free will, where matter can do just whatever it wants. But I still have a problem with it, even in that form, because as you maybe know, the basis of quantum mechanics is the Heisenberg uncertainty principle, and that says that, for example, you cannot know the speed and position of a particle with infinite accuracy. The more accurate you know the speed, the less accurate you know the position, and in that way, often compared to taking a picture, if you have a very high shutter speed, then you get a very sharp image, but you don't know the speed of whatever the bird you're photographing. On the other hand, if you take a slow shutter speed, then you can see a blurred bird, so you can kind of estimate how fast it is going, but you don't know where it is. And that is the basis for quantum mechanics. And so the statement that exactly the same starting situation can lead to different outcomes, of which only probability can be stated, can be calculated, has a problem in itself, because what does exactly the same starting point mean? You have two pieces of matter, and exactly the same, that means that they need to have exactly the same position and exactly the same velocity, and then lead to different outcomes. But you cannot, there's no exactly the same when it's subject to the Heisenberg uncertainty principles. You don't know what the speeds and the velocity is. So if you shoot a bunch of electrons on through a slit, and you say, well, they are all exactly the same before they go to the split, but then afterwards when they hit the screen there's just a probability, and no, you cannot say for certain, according to your own theory, that that the situation was exactly the same, that these electrons are exactly the same, and that is the problem with all of these conclusions. Also with radioactive decay, for example, they always say, yeah, there's nothing you can say about radioactive decay when a particle will decay. You can only say that there's a probability of such and so much that this atom will decay, and when you have a bunch of them, a whole lot, then you know that half of them has decayed in so much time. But there's nothing you can say about an individual. It's completely random when it decays. But you cannot know. How can you know that? Then you have to know the position and the momentum of every electron in this atom, and every neutron, and every other quark that is in there, right? And you cannot say that because you are bound by the uncertainty principle. So you cannot claim that all these atoms are the same. So it doesn't mean anything really with exactly the same starting point leads to different outcomes, according to my understanding at least. So it's another short video. Let me know if I make any serious errors, small errors also. Interesting. Thank you.